Hello and welcome back to compiler programming. The next step for us to start creating an executable is to introduce a concept of a program, because right now we just have these functions that are sort of floating in the void, and we did introduce this buffer somewhere. Let me find what it looks like. So first of all, I will add bookmark here, and I want to go to here. Yeah. So we have this function buffer that we use to lay out all of our functions, and we then can use relative jumps to go between them, which is good. But in program, this is not gonna be as easy. So one of the things is right now we so there are a couple of things that are at play here. We always expect a function to be defined before we call it, and we expect this function to be encoded before we encode the next one, so that we know what is the address of it. And maybe for now we will keep it that way, but eventually it's something that has to change. Anyhow, for now, what I want to do is I want to wrap this function buffer in some extra type that we will call program. And we'll see how we deal with this stuff for JIT, because we'll have essentially now two branches of code. We'll have something that works for runtime, and then we want to eventually put it in executable, and they will probably do slightly different things when dealing with addresses, but we'll see how that plays out. For now, I guess the difference will be, I will say that we have program test program, or program star test program, I guess, maybe. Doesn't really matter if we use it on the stack or on heap, I guess. The point is that here we want to replace this and say that test program is program, and the program will have these I guess it will have this function buffer, but it will also have a space for data. So the hacks that we do right now to put rep relative stuff at the start of the at the start of our code is not very nice, because we are still, like, the permissions are wrong, and in general this is not supposed to be that way. Especially if you have a mutable variable next to your code, that's actually very bad, because it will invalidate instruction cache on the processor and will drop in performance heavily. So, like, it's not what you should be doing. So we should have this function buffer, and I guess so it's kind of tricky to keep the structure as we have it right now and do what I want to do, because I want us to move to the situation where we have kind of this this function buffer, and we also have data buffer. And the reason this is tricky is because we end up with a situation where there is technically no guarantee from operating system that when we reserve these two things, that they will end up in the right, like their addresses will be close enough to each other such that we can refer between them with 32-bit offsets. To mitigate that, we would need to use something like allocate a flat buffer and then change permissions on the part of that buffer. But I'm not sure if this is the first step that we will make, or we will just rely on accidental fact that they should be close to each other when I do two allocations like this, but we will see. Okay, we need to free the buffer, and this is going to be program function buffer and program data buffer. Okay, let's see what happens when I try to build this. Okay, yeah. So the problem right now is function expects to have that function buffer, but we need to change that definition to be something else. So let's search for define function. That sounds good. I will split it in a different line so it is a bit easier for us to understand what is going on. Like so, and like so. Okay. Yeah, so the function gets passed a function buffer, and instead we want to pass program to it. How did I call this? Yeah, I just called it. Okay. So it actually is test program, and we do want to define. Maybe I want to pass a pointer directly. So here I will not do like this, but instead I will do program underscore. And for tests, I will define it globally, but later we will also add the tests that will just wrap it locally. For now, I want to keep the functionality that we have so we don't lose stuff unnecessarily. Program underscore, and this program is going to be an address of test program. I said test program. Okay, program underscore, and of course it has no idea what the hell the program is, so that's something we need to fix. Let's put it close by to the function builder because they are basically very much connected. Type def struct program, and then we have buffer function buffer. Does my buffer return a pointer or a real thing? I think it returns the actual buffer. So I think it's like this, and then buffer data buffer. Okay, this should be semicolons, program underscore undeclared identifier. That happens because we have another suite of tests, and there we are doing slightly different thing, which now needs to be exactly the same way. Where is function buffer here? Okay, let's grab it, and we'll need to replace with the same stuff. Okay, can just copy this thing, put it over here, and move this stuff closer to the spec. I can also move it inside of the spec technically, not make it global, but do it like this. static program. Yeah, that would be fine. I can actually move it here as well. And let's see what is going on. Okay, something is unhappy because I ended up with incorrect copy paste. It's good. Function buffer undeclared identifier, that's okay. This is our reprelative stuff, which we'll need to fix. So that's okay. For now, I will comment it out and add a marker to here. I want to check that the rest of the program actually works. Okay, here is a bit of an issue because we need to pass our program now into this stuff and say program underscore. Okay. Create character. Let's call this. Okay, now we have only one issue, and that is that the function stuff, function builder, or more precisely function begin, it expects to get a buffer, but instead it will now get a program pointer. Program, and we can very easily say that buffer star buffer is program function buffer. Okay, this is like this. Okay, getting further into our stuff. Okay, more things connected to the reprelative addressing. Again, this is what this stuff is all about, so we are removing these for now, and let's see where it leads us to. Okay, so this is not actually relevant at the moment. We will do it inside of the program. And we have this make add to and make identity. Honestly, probably should be just, we should just get rid of these. It will be easier to deal with this stuff. Are they even used? Okay, yeah, they are used. So one is here. Yeah, it was an example of parametric polymorphism. Okay, that's fine. We can just add this to here and be more explicit about it, and jump to here and say program. Okay, add to and declare the identifier. Oops, I managed to remove this stuff. Okay, it looks like we are building just fine. There should be no problems with the test, but you never know. Okay, tests are also running. Okay, now we are ready for the next step. In particular, next step has to do with this stuff. We want to reserve memory in the program, not inside the function buffer. So let's make that happen. I guess what we could do is we could try to first compile functions to some temporary memory, figure out what is the size of those instructions, and then figure out what would be the right size of the buffer. But that can be done later, I guess. For now, this is the stuff that I want to get rid of. So in the first pass, we will just do this program. Data buffer. Program data buffer memory. Okay, let's see if our virtual Alex end up in the same rough space, so that 32-bit addressing works fine, but it's quite unstable. Okay, it does work fine though, so that's good. But now I want to create a helper that will reserve this space automatically, so I don't have to copy paste this stuff all over the place. And that means that inside of this function we have, for example, we have value register per descriptor, or we will have something like value star value global. Yeah, value global sounds good to me, because impers will be actually treated separately from the globals. If you remember, in executable, they are in different sections. So yeah, that's why they will also end up in our program abstraction separately. Okay, we do buffer append. Here it's actually going to be slightly different. Let me think about this. So first of all, this goes into the body of the function, not in the parameters. In parameters, it will need to get program star program, and it will also need to get a descriptor. Descriptor star descriptor. Okay. Now what I will do is I will say U32 byte size is this stuff, descriptor byte size, but instead of hard coding descriptor as 32, it will be whatever descriptor we get passed, right? Because we can reserve any amount of memory as global, right? In C, I could very easily write char foo and then say, 10 kilobytes or whatever, almost 10 kilobytes. So this is what we are doing, right? We are creating a global variable inside of our program that will be stored in a different section of executable later, and for cheated code, it is stored in a different buffer that has different permissions than the default one. Okay. Getting back to this, so byte size is byte size, and here I will do this stuff. So basically, no, offset is actually not that. So this is completely wrong. We'll need to do some different stuff. Okay. also writing to this memory is going to be quite tricky for the parent C process or C program, but we'll figure it out. Okay, value star. First of all, this has to be value star. Let's call it result is temp allocate of value result star result is value and descriptor is whatever descriptor get passed to us. Byte size is byte size, and then the location. So we should have something like void star address, and this is the tricky part. Basically, we will need to see buffer. So we basically do memory plus occupied. Where was I? I was here. Program data buffer memory plus program buffer occupied, and we can do buffer allocate size actually. This is gonna work great for us. So we say buffer allocate size, and the buffer is this one, and size is gonna be byte size. Okay, that sounds good. Address and address. Okay, and yeah, I guess that's fine. So we can return result. Okay, going back here, I will leave this as a reference if in case I've messed up somewhere. And now do value star rep is, or global is value global of program and what, and descriptor S32. Now we want to put 42 in there, as what I mentioned, that it's going to be slightly tricky now to do that, but it's still fine. So what we do is we say global. Well, let's first do a check. So we check that global operand type is operand type rep relative, and once we do that, we can safely say global operand. What is it? Here. Im64. So this is address in memory where it is, and for now we need to cast it to S32 star. So we can do just S32 star address, and we can write that address. We can say star address is 42. So if I haven't messed up anything, then this is what we end up with. Buffer allocate size, too few arguments for call. So here should be global now. Buffer allocate size. It has a buffer, and here it's called program. not convert. Yep. Good. So let's see if it's better now. Okay, it still works. That is very, very encouraging. And one thing that we can do is we can say that we can actually create two globals. Yep. Let's say that we create one that is 32. And then the other one will be 10, and we sum them here. So we say plus A and B. And we call this, let's call them global A and global B. Okay, global A. And then global B. And previously that wouldn't have really worked because this calculation was actually completely wrong. It was always assuming that it happens at the very start of the buffer, which is not how it's supposed to be. Now we say B, 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 and oops, global A, global B. Cool, we still build. Actually now it's wrong, but I want to see the test fail. It's always nice to see the test fail. And it's modern fails. It actually fails to find the encoding for this stuff, which is good to know. It's something that we can fix. Let me fix the actual test because we have a failure for different reason, and I want to accidentally forget that we have a failure for different reason and continue debugging it. If we look at the, I'm not sure, I remember if it is inside encoding or inside instruction or inside value. Somewhere we have this stuff that we use to print. Yes, this is the the thing, and here we can say percent percent what? Percent LX. So basically it's this stuff, I guess. It should be 32 bits though. Okay, no, it's in this case it is 64, and the same as here. The representation will be slightly misleading because at the point that we're going to be printing, we don't actually know what is the offset from the rep. So let's not show it this way, but something like rep to this offset. Yeah, something like that. Maybe like this. Okay. Not really useful, but much better than XXX, I guess. Okay, let's start the debugger and see what is going on. We have to change our executable, which is fine, we can do that. Okay, did not find acceptable encoding. Let's look at the instruction. Move, that's fine. Operands, we have indirect memory that refers to a register, and then we have rep relative stuff. Well, that is very much true. There is no such encoding. You can't move from memory to memory, and rep relative addressing is memory. So now we need to figure out who is doing that. Plus or minus. So yeah, we're reserving stack, and then we are moving to stack one of the values. So that's, by the way, this temporary is also redundant. We could just use this one for our stuff because the result will already be there. So why are we doing it? We all could, like, we will also switch probably these two. Yeah, there's definitely stuff that can be done about plus and minus to improve its encoding and performance. Maybe it would be a fun video someday. For now, I'm more interested in move value, and move value needs to learn how to deal with the fact that you have two memories on your hand. So here it goes. If we have, I guess we need a helper function, something like bool is memory operand, and then it accepts I'm not sure if it should accept a value or operand. Operand probably will be more nicer to deal with. So we say operand star operand, and like so, and we say return, and then a bunch of options. So if it is turn operand type memory indirect, or operand type rep relative, or operand type, do we have anything else? I guess this is all we have that is memory. Label, and sort of, we'll see how we deal with label. Technically, you should never move to label, like that shouldn't be a thing. So maybe we should just assert that in the code. Okay, that's our helper. And if we say is memory operand of A, and is memory operand of B operand, in that case, we need to do something with one of them. And in particular, we do the same trick as we do here, where we create a double move, right? So we say that we move one of them into A, and then we move through a register. That sounds fine. Okay, and return. The thing is that this will not do any of these optimizations, but they are not targeting at memory anyway. They are all about immediate, so I think that's okay. Good. We can build, I guess, but what's the error? Cannot open file. Function spec. I wonder who is holding up the. Not sure. Okay. So, is this a persistent issue? Looks to be. So something is not okay. So this passes, but the next one doesn't, which is exactly our code. Operand, im64, mode and start address. Yes. This, I'm not even sure how this worked before, because this is supposed to fail even last time when we did this, which is very, very strange, but okay. This assertion no longer really makes sense. Where is it happening? Is it here? Is it in encoding? Yeah, so this is about the reprolative stuff, and instead what I want to say here is something different. I want to say that this thing fits into an S32, which means so we have start address. Let me try to figure this out. We have start address and then buffer occupied. Okay, this figured out what is the address of next instruction. That's fine. And we have this stuff as 64 diff is this. And then what we want to do is to try to check if it fits into 32 bits. And we need an absolute value of that. I'm not sure if abs is defined somehow, but we can do it ourselves. We can say diff equals, or do we even need absolute? No. What we need to do is assert that diff, actually that's use64 of diff, or even no. Let me think about how to do it correctly. Because, yeah, we do need absolute. So the way we do this is we essentially want this, and then convert this stuff to U64, and then assert that the result of all of these is less than 0x. ff, 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 but here actually it should be 7. Okay. This is what we want to know. Or we can... Actually, we can probably do it like this. Diff less equals to this, or actually and diff more than 0xff. Not sure if I should explicitly cast them. Let's see what happens, how C treats this stuff. Yeah, here it should be diff. Maybe there is safe truncate. I need to figure out how to better do this. I'm honestly not very familiar with safe truncation in C, something definitely for me to look up. Maybe I'll do it till the next video. For now, that is fine. I have encoding open twice, which is not good. Let's check out again. Do we have this assertion somewhere else, or I forgot to remove it? Ah, I forgot to remove it. And address. Yeah, we don't need an address anymore. Cool. So that's great. Now we are getting closer to what we want to have. Yeah. So now we can correctly define global values, which is going to be very, very useful when we again start writing out executables and they live sort of in a separate chunk of the code. We might want to change how their address is stored, to not store it as immediate 64 and instead have something like a concept of a section where we say, okay, this is the offset within that data section, and then then we calculate the actual address from there. But this is an enhancement that we can do at a different time. For now, the last thing I wanted to do today is to restore this stuff that was broken by me. So let's do that. Oops. Too much. It should be like this. And in particular, we need to also have this stuff. Now, these also can go into the same memory, same global, because this memory is not where the function actually is. This is where we will write a pointer to that function. So this goes exactly the same as the other one. We do this, we do this, but in executable we'll go to import section, so maybe we will also work on a more explicit import section. So yeah, I'd say yes. Okay, like so. Descriptor is it doesn't really matter what descriptor is, I guess. Oh no, it does. So this should be a pointer in reality. So I'm not sure why this is happy with it, but because we are only doing byte size on it, so it doesn't really matter if it is like what is the operand here. Okay, guess the handle value is this. Oh, I'll just say that it's a global. So we'll need to update this C function value to basically do value global, but that's something I can do off camera. For now, I will continue on this stuff. Okay, this looks good, and we can pass here, get handle value, descriptor. No, not exactly. We want descriptor pointer to. So we have a pointer to a function. And this is what will be stored in this stuff. Okay. Yeah, this definitely needs to change how it's done. Append 64, yeah, that's no longer a thing. We are building just fine. Let's see if I may start the implementation. Looks like I didn't. And now we have a very nice setup. I'm not super happy about this stuff. As I said, like, if we want to continue to have like a nice macro DSL for embedding this stuff into C, then something better has to happen, definitely. But for the eventuality when we're gonna build this out of textual representation, this is perfectly fine. I'll think about how to best handle this later. For now, let's recap. We added this program abstraction, so we are now splitting the memory between the code and the data. Firstly, that's good for security, even though our security in general is non-existent, but at least now we separate the code part and the date part. And then it's also good for because it brings us closer to how executables are actually done and prepares us for that a bit more. Cool. With that, I guess that's it for today, and hopefully see you next time.